So as a welcome, everyone. Please be aware that after this session, we will send you an email and ask you to decide what your action plan is going to be in the final session, which we will have in the new year. And it could be obviously that you become a trainer in your own university. I had already someone contacting me from Peru, which was really nice, who wants to embed the training into his university. So please do think about it. It could be also other things. So it could be that you become a trainer yourself and you embed it in your university, but it could be also that you do a social media campaign, that you try to develop, write a cookbook on low carbon meals, or whatever you want to do. As we ask you after the session in an email what your focus is going to be in January, so that we can also prepare, because we are going to put you into groups of 4 or 5. And then obviously we have facilitators coming into your groups to help you also to make your action plan and to make it ready, and to maybe share some ideas, brainstorm together with you. So it would be really nice if you let us know what you want to do in session 4. Okay, and today hopefully you get a few more ideas. So I will start to give you an overview. So today is a session where we do a lot about the climate science. And it's a climate science in linked to the high impact carbon solutions. It's not on its own, it's really linked to the high impact carbon solutions. So we will do the whole lot of the climate science. So we will start quite basic, because when we ask you in session 1, how much do you know about climate science, we had some people who were actually very informed about it, and some others who were just said they only know very little. So we have to cover for everybody. We have to really start from the beginning and to go all the way to the more complicated issues. But when we also ask you in session 1, if you are really more of an expert in this field, you said, as a 4 of you said you were more of an expert in this field, and you put your names into the chat. If you are here today, I did not contact you before the session because I hoped you would be here. If you're here and you're willing to share your ideas on Carbon Sync, if you could now put information in the chat again, and Rajul and Ashley will pick it up and tell me when we come to Carbon Sync that you are actually willing to share your own research or whatever you know about the Carbon Syncs, and we will make sure that you have a chance to talk about it. And I think this can be quite exciting, because we had recently a session with a lot of people from Australia, and they talked about the blue carbon and research they do around blue carbon in Australia, which was really, really interesting. So if you have something to share, please do put it in the chat, and we give you a chance to talk later, or you can just, as if you don't feel so comfortable speaking to everyone, just put the information in the chat so that we can all read it, which would be really nice. So this will be the first hour. And then in the second hour, we will talk about carbon calculation. So it's really to give you an understanding what are high impact solutions, what are low impact solutions, and how has it been calculated, and how can you actually make really informed decisions. And we will talk about a book where someone has actually looked at all the different calculations and gives you a bit of an idea how to do it. But obviously you can also start to, as with all the tools we are using in the second session, you can also explore it in the background and really start to do your own calculation from scratch, kind of, if you want to. So we will have different activities there. We will have first an individual activity where you look at different beverages you like. Also, for example, if you really like to drink a glass of wine or something, you can look it up how much carbon would be involved there, or tea or coffee. But we will also talk about food in the first activity. Then we will look at a whole meal, to how to make a carbon-friendly meal. And then we will have a quiz, which is covering other topics like emails, for example, going with a bicycle to something, to going with a plane to a location, and so on. So this will be the quiz at the end of the session today. So I hope you will enjoy it today. It will be quite a lot to information, especially if you are more starting to get to know about climate change science, but hopefully it is entertaining enough to keep you busy and to keep you entertained in the next 2 hours as well. So the learning outcomes will be that you learn the basics of climate science, that you learn which action have a high and a low carbon footprint, and that you will be able to adopt high impact solutions that will reduce your own carbon footprint. So the focus on the session is really on the individual action. So what can you do personally to change your own carbon footprint? But obviously all these things we are suggesting and we are talking about can be upscaled. So for example, if you would, when we do the food, for example, if you kind of You can obviously decide to change something in your own diet, and you can change things there. But you could also upscale and say, okay, if we would change this in the catering of our university, so if we, for example, have a meat-free Monday in our university, or we kind of change generally that every day, as I don't know if it's a possibility already, but maybe if every day there would be a vegan option available at your university, what change would it make then? And you might actually, in your action plan next in January, you might decide, okay, my action plan is actually how could I convince our head chef, the people running the catering at our university, to make more carb-friendly meals. This could be one of your actions, or the key action you want to focus on, where we put you together with others who have the same aim. So as I say, it's mainly for your own carbon footprint, but it can be upscaled to include more people and can become your work or collective commitment. If you want to take notes today, the answers or things you encounter today are especially for the question 2 on your assessment form, but also maybe a few ideas for question 3 on your assessment form. So you can put a few information there. And and at the end of the session, I will stay behind for questions. I hope that Scott will make me host at this time so that I can stay behind with you. And if you have any questions, please do stay behind and I can answer these questions. Okay. So as I promised, the climate change, we won't be able to cover everything, because you can imagine that everything which you see here on the screen, there are scientists working on it for years and years. Alone, for example, if you study agriculture at our university, at Nottingham Trent University, and you would study agriculture there, you would have a whole module alone on soil as a carbon sink. So you would go into a lot of detail there. So obviously I can't cover in a few minutes what they learn in 20 hours. So you will get only a basic understanding, but hopefully this will be enough for you to really have an info that you can, whenever you explain to someone what the high impact climate solutions are, that you can explain it with a good understanding of climate change science. And obviously, if you want to understand it all more, then you can obviously go into more detail and you can try to learn more about the soil as a carbon sink, and kind of either do more, as even do a degree in this or something, or to explore it more for yourself by looking things up. So, but as I say, we will not cover everything, but we will cover everything you see on this picture in a little bit. First thing we are going to do is to, I will share a video with you where you can actually see how how scientists measure carbon dioxide. Yeah, and this is some people said they didn't know so much, so I thought we start from the beginning. So you will see first how this is actually done by scientists. No, I think it has gone away again. So.
We're here at the tip of the Scripps Pier at UC San Diego. The occasion is the 60th anniversary of the start of the Mauna Loa carbon dioxide record. This was a record begun by my father in 1958, tracking the increase in carbon dioxide in the atmosphere. This is a place that my father actually used to test methods that he later used in Mauna Loa. First step is taking an air sample, and this is a glass flask that's been evacuated, and you take it out to a place where you have a clean shot of air, and you simply open this thing up, and the air rushes in here, and you capture a sample, and then you take this back to the lab, and you analyze how much carbon dioxide is in it. This is the original lab that my father did the carbon dioxide measurements in, and this device here is called a manometer. The manometer helps you measure the amount of carbon dioxide in air. It's why we know that the carbon dioxide levels were much lower at 315 parts per million back in 1958. After the flasks are brought back into the lab, they're mounted here where they're analyzed for carbon dioxide concentration by sending the air sequentially, one flask at a time, through an analyzer. When the analysis is done, we then mount them here where the air is pumped away. The carbon dioxide is retained in these little glass tubes where it's subsequently measured for its isotopic composition. That helps us decide whether the carbon dioxide, say, came from a car, or it came from a plant, or it came from the oceans. When my father started these measurements in 1958, 60 years ago, the concentration levels in the atmosphere were around 315 parts per million. Today, 2018, we're up essentially approaching 410 parts per million. Why? Well, we keep burning fossil fuels, the carbon dioxide keeps building up in the air. It's essentially that simple.
Yeah, so this was the first introduction to how it is measured. And you will all, maybe all have heard about the parts per million. Do you know where we are now in 2020? Do you know the most recent? If you know it, please put it in the chat now. And you can imagine that these measurements are obviously not only taken at one part in the world, they are taken all over the world, and you see everywhere a similar pattern. So the parts per million are rising everywhere, and you can see these graphs kind of wherever you measure it around the world. Yeah, so you want actually, do we have an answer in the chat where we are at the moment?
We have an answer from Valentine who says it's 417 parts per million.
Yeah, that's good. This is approximately around this. And if you want to look this up, I don't know, Valentine, where did you get the number from? Where did you see it? Maybe if you could say something.
Sorry, I was heating. It's from WMO, which is the accumulation of, I don't know how many data sets, but it's from NOAA. Yeah, it's on the graph.
Okay. Ah, okay. So at the end,
what was the question?
Where you got the number from? Also where, was it in the newspaper, or did you look it up or something? Or
I think I looked at it at on NOAA's website, and they said that it was the peak that was reached.
Yeah. Okay. Good. I mean, if you in different, I think people might know that in the UK we have The Guardian, which is a newspaper which is called The Guardian. And The Guardian, for example, offers you that you're for free that you can sign up for all the green information, like climate change or anything environmental related, and you get it once a week. So once a week you get all their articles around this topic, and at the bottom of these articles you will always find the parts per million for the week. So they will always tell you where are we in this week, and they give you the number, and they will also compare it to the number we had the previous year. So it will actually tell you, has it still be higher than the previous year, or has it gone down? And unfortunately, at the moment, even though we had COVID and lockdowns everywhere and things, it hasn't gone down, because often the parts per million are reacting to something we have done a few years ago. So often you will not see it immediately, but hopefully eventually when we do the action, we will see the difference. So if you want to actually always be informed about the current level and whether we already start to make a difference, you might want to sign up there, or sign maybe Valentine, if you could also share where you saw it, so that people maybe can get the information from there if they are interested to see what the pattern is. But the parts per million are really important for people to, who want to follow, are we actually still doing the wrong things, or are we getting better? So it's a very good thing to follow. The other way of measuring it, the parts per million, is to use the ice core measures. And as I said, we had a few who were very knowledgeable about climate change. So maybe someone else wants to explain this method. So if you could just speak if you want to explain this method.
Maybe I can try to give an explanation.
Yeah, good. Okay, great.
So basically what they're trying to do is they go in Antarctica, and they're like digging in the ice to get carats of ice, and they bring these carats of ice in a lab. I think I don't know exactly where in Europe. I'm wondering whether it's in France, but I'm not sure. And then they cut like small pieces of these carrots, depending on like how deep it is. And then they basically melt these pieces of ice to measure the quantity of gases there is inside. And because like the ice is falling in a kind of homogenic, like the snow and like precipitation is falling in a homogenic way throughout history, we're able to go back hundreds of thousands of years ago to identify basically the concentration of greenhouse gases there was really like a long time ago. Yeah, pretty much.
Yeah.
So like 800,000 years ago, I think.
Yeah, no, great. No, it was a very good explanation. So, and you're right, the ice core reveals the historic levels of CO2. So you can go back, like you say, 800,000 years, because you can imagine the further you go down on the ice core, the further you go back. And this is why we have these measurements, because obviously the other measurement you have just seen in the video is one which we only do since approximately 1955. So we only get the years since 1955. But with this method, which you see here on and which was really nicely explained now, you can go all the way back. So you get these records going backwards. And here you can see it, like how was it 800,000 years ago? And you can see that there is a fluctuation. So it was always going up and down. But what is different now is that actually, if it would have been a natural pattern, we would have gone down by now, also long ago, like more 1910 or so, because then there would have been a peak and then it would have gone down again. But because it's not going down and the parts per million are still increasing and increasing and increasing, this is why we know, as it's one of the indication we have, why it is actually man-made and why we actually have, as why humans are causing this, because you can see in this graph that since 1880 approximately it's going up and up and up, because this is when the Industrial Revolution started and people started to have put more and more carbon in the atmosphere. And this is why we know it is actually climate change is actually introduced by humans. Because of this pattern. A natural pattern would have gone down if it would have been just caused by the normal things, and it would have stayed in the same pattern as before. So we had this video as well. So I show it to you again. We had it in session 1, but if you can observe, pay close attention and tell me afterwards, either in the chat or you say it loud, which was the year when all the countries turned red and never went back to blue again, as that they were always higher in the temperature, every country in the world, and there was no blue anymore. So observe which year it is, kind of, in this video. Okay, did you get the year when we suddenly had everything was going, it was going up? So do we have an answer in the chat which year people say when we had suddenly every country on red and higher temperature?
Answers coming in, Petra, around 2000, 2003. Yes, many say it was around 2003. Some feel it was around 2000.
Mm-hmm.
Yeah, those are the two main
answers. It's approximately, you can, as a kind of approximate, say the last 20 years is when we had every country in the world has higher temperature on average. And you did see it also last week in session, not last week, when we had session 2, that actually the global average temperature has risen in the last 20 years. If you remember from Al Gore, the kind of graph I shared with you, it was also the last 20 years, every year the average temperature worldwide was higher than average. And obviously, if you then look by country, you have the pattern as well. And as every country has a higher temperature as before. And what we hear mostly in the newspapers now is that people talk about higher temperature. And so they are warning us not to go above 1.5 or 2 degrees. And this has replaced really in many countries as talking about the parts per million. I think the reason is that a lot of people couldn't really understand what the parts per million mean and when it becomes dangerous for us. So therefore, they started to talk about the temperature, because everyone, I think, in the world can understand that if we go higher and higher in the temperature, then we will have changes to the climate. We will have that it's getting hotter than we maybe would like it, that it gets also more changeable with the weather pattern and so on, because we make a major change to the climate. So in most countries, I think temperature is used, but I would like to ask you all whether when you read the newspapers in your country, whether it's parts per million or temperature. And if you could put the country in brackets, so if you say if it's parts per million, so ppm, you can shorten it ppm, as you can see here in these newspapers, or whether you use temperature, that the newspapers or the news, when they are talking about it, use temperature. If you could each please give an answer. And Ashley and Rajul will try to summarize it very fast, what most people say.
Lots of answers coming in. So Australia and Canada, it's temperature. Temperature in Denmark, UAE, France, Costa Rica, Mexico, Peru. So mostly temperature being used. In Russia, it's both ppm and temperature.
Okay.
Some say both in France. UK, it's often temperature, but have seen ppm as well.
Okay, it's interesting. Okay, yeah. Well, I think it's interesting how it's different in some countries. Yeah, and I think what I heard, I don't know if it's true, that people, as young people who are very engaged in the youth climate movement, that they introduce each other with that they tell each other the year, as the parts per million in the year they were born. So instead of saying I was born in 2000 or something, they kind of give the parts per million of the year and tell people the parts per million. So which I found quite interesting, that it seems that a lot of people do this. And so I was teaching yesterday students here at Nottingham Trent at the university, at my university, and they all started to calculate their own year. So they gave all the information in the chat saying when they were born and gave the parts per million of the year they were born. So I could have actually got an overview of when they were all born, the people who took the class yesterday. But apparently this is really the case for people who are really interested in the youth climate movement. Okay, so then, but as I say, it's parts per million temperature, it's both kind of as information is useful, whatever is used, but I think the most important is that we really neither should go up, neither the parts per million nor the temperature should go up if possible. And I want to remind you of this slide again, which we also had in the session 1, that the scientific consensus that climate change is caused by humans, so that we have this temperature increase or the carbon dioxide increase, is actually that scientists agree that it's 97%, by 97% it's caused by humans. So it's not a natural pattern. Most scientists say 97% say, no, it's actually not a natural pattern, it's caused by humans, it's actually what we have done. And this is why we have more. So we want to now ask you to say, as a lot of you will know it, but if you would like to see in a word cloud what you know about the greenhouse effect and how you would explain it, we are going to use Menti for it. So you need to kind of put into a telephone or on your screen menti.com. Put the code in, and then by typing in your own words, you will create the word cloud. And I think you have maybe done it before. So we will see what most people are choosing. And to do this, I will now stop sharing my screen and hand over to Ashley, who has prepared this. So she has the slide where all your results are coming in. So the first answers are coming already in. A lot of people saying as a blanket is a good expression for that, it's like a blanket. Then it's accumulation of heat. Warming gets bigger now, so more people are putting warming in as a greenhouse effect. Yeah, trapping the heat in different ways. People express it in different ways. Accumulation of heat as a good one as well. Gas that traps heat is a very good expression, is very well done for for using only a few words and trying to express it in a very short way. Yeah, so you can see this is, as I think most people have used warming as a, that this is an explanation that greenhouse effect is causing the warming. Yeah, good. Okay, so if you stop sharing again, and then I will go back to share my screen and the point. So can you see it? Yeah? Yeah? You see my slide?
Yes, we see it.
Good. So let's see if this is, it's working today. This is good. But I think Ashley is on standby in case I'm disappearing. You can show the video, no? Because I say yesterday it went black suddenly in my computer. Okay, but hopefully this video will work and will explain you again a little bit the greenhouse effect, but also effects of climate change generally. So even if you know a lot about it, hopefully there's still something new for you in this video.
Human activities, from pollution to overpopulation, are driving up the Earth's temperature and fundamentally changing the world around us. The main cause is a phenomenon known as the greenhouse effect. Gases in the atmosphere, such as water vapor, carbon dioxide, methane, nitrous oxide, and chlorofluorocarbons, let the sun's light in, but keep some of the heat from escaping, like the glass walls of a greenhouse. The more greenhouse gases in the atmosphere, the more heat gets trapped, strengthening the greenhouse effect and increasing the Earth's temperature. Human activities, like the burning of fossil fuels, have increased the amount of CO2 in the atmosphere by more than a third since the Industrial Revolution. The rapid increase in greenhouse gases in the atmosphere has warmed the planet at an alarming rate. While Earth's climate has fluctuated in the past, atmospheric carbon dioxide hasn't reached today's levels in hundreds of thousands of years. Climate change has consequences for our oceans, our weather, our food sources, and our health. Ice sheets, such as Greenland and Antarctica, are melting. The extra water that was once held in glaciers causes sea levels to rise and spills out of the oceans, flooding coastal regions. Warmer temperatures also make weather more extreme. This means not only more intense major storms, floods, and heavy snowfall, but also longer and more frequent droughts. These changes in weather pose challenges. Growing crops becomes more difficult. The areas where plants and animals can live shift, and water supplies are diminished. In addition to creating new agricultural challenges, climate change can directly affect people's physical health. In urban areas, the warmer atmosphere creates an environment that traps and increases the amount of smog. This is because smog contains ozone particles, which increase rapidly at higher temperatures. Exposure to higher levels of smog can cause health problems such as asthma, heart disease, and lung cancer. While the rapid rate of climate change is caused by humans, humans are also the ones who can combat it. If we work to replace fossil fuels with renewable energy sources like solar and wind, which don't produce greenhouse gas emissions, we might still be able to prevent some of the worst effects of climate change.
Yeah, this was a bit of an overview about the greenhouse effect. I think the most important thing to memorize from it is really that the more we are putting any greenhouse gas into the atmosphere, the more we will actually increase the heat, because each of these little molecules will trap more of the heat, and therefore we get the temperature will come higher and higher, and then we'll have all the effects we have just seen in the video. So one of the things we have to really look for our high impact solutions, how can we reduce what we are putting in the atmosphere? How can we reduce, for example, putting methane in there as a greenhouse gas, carbon, and so on. And the other side of it is that we, of our solutions is how can we increase carbon sinks? So this is the other side. So not put even more into the atmosphere, but how can we actually get more into carbon sinks? So I've given a bit away what carbon sinks are. Some of you said in session 1 they have no clue what carbon sink is, which is fine. Maybe give just a guess now. But if you have a bit of an idea what it is, or if you can really explain it what it is, please do again try to capture it with up to 5 words approximately. And we are doing another word cloud with this. So if you go to Menti.com again and put the number in. So I will stop share again, and Ashley will share the results. Rajul, do you want to comment on things?
Yes, Petra. So lots of inputs coming in. Carbon storage is one of the biggest ones. Capture, storage of carbon, reservoir of carbon, entity which absorbs carbon. Yes, we pretty much right. Sequestration, natural carbon storages, oceans and trees, and that's interesting. Reservoirs, carbon stored. I think we pretty much, yes, hitting it on the nail. Photosynthesis and oceans, yes, that's so important. And anything that traps carbon, peatlands, that's good to see. And so, yes, those are all entities which store carbon, and those are all correct answers. Over to you, Petra.
Okay, thanks, Rajul. So I start sharing my screen again. So this was really good also that people mentioned peatlands, which not many know about. So this is much more detail already, which is great. And I don't know, Rajul or Ashley, do we have someone who wants to share also what they know about carbon sinks in the chat of the 4 people who said at the beginning they would like to share? Do we have anybody here again, or maybe they don't want to share now, which is fine as well. So do we have anyone who has volunteered in the chat?
Ashley, do you see any inputs?
I don't see anything quite yet.
Okay. I mean, obviously you can still volunteer if you want to. So I will shortly talk a bit through carbon sinks because it's really, really important to understand this. And you have really, in the word cloud, most of the answers were there. But it's really how actually something can store carbon. So it's kind of either that there was carbon stored anyway for a long, long time already, or that they actually can take things out of the atmosphere and store additional carbon, so which wasn't stored before. So, and one of the big carbon things we have is obviously, you mentioned it, are the oceans. Peatlands are another one. And forest trees obviously are very big, store a lot of carbon. And one which is often not so well understood yet is soil. As a soil is a very, very big carbon sink. And soil is also where you can make a big difference. And a lot of people have started to really do the research around soil and try to understand this better now. Because in some areas, like for example, I was working with a company, and I can't mention the name of the company because it was confidential work. They, for example, were working with fruit or vegetable in the supply chain, which was produced by 45,000 farmers in their case. And the way the soil was now treated since decades already, as the new farming methods they had used for decades, had actually depleted the soil as a carbon sink. So while before the soil was able to store about 45% of carbon, now it had gone down to only 5% of carbon. So it was much, much lower than before. And this is because of the farming methods which had been used in this area. And they realized if they change the farming methods around this product, they could actually get the soil up to 45% again. So they could actually get carbon out of the atmosphere, bring it back into the ground, and 45% in the soil could be stored as there could be carbon stored in the soil as a 45%. So what they decide to do with their suppliers is to say, you have to really change your farming methods. We give you 3 years, we give you all the teaching tool, all the material, how you can change it, but you need to change how you farm this product. And so they kind of really told their suppliers how to do it. They kind of gave them instructions and everything, but they also told them, if you don't make this change and in 3 years the soil is starting to become a better carbon sink again, you can't be our supplier anymore. We have to, because we expect it from all our suppliers to do this. And I think this is really good because this is really one of the high impact solutions, because you can imagine if a company is telling 45,000 farmers to do this change and they all go back from 5% to 45% and increase the carbon sink of their soil this way, this already will make a change. And obviously we get much, much more carbon out of the atmosphere this way. So this can be one of the high impact solutions. And to give you a bit of an understanding what this could mean, for example, how you can improve the carbon soil as the carbon sink of soil, is as I give you an example for the UK and Germany, where I know a little bit more about. What can be done here is, for example, but I think it applies also to lots of parts of the US, is to actually have crop rotation. So it's kind of means that you every year you actually plant something different. So one year you might plant corn, the next year you might plant wheat, the next year you plant rye, and then it's really important that in the 4th year you put something on like lupins, which is all, also you might know it better as beans or peas or something. So all the beans, you know, red beans, green beans, black beans, they all belong to the same family, and they all help to actually increase the carbon sink of soil. Yeah, so therefore, and this is kind of important for all the lands to actually make these changes. To in agriculture, you change it every year, and that you don't have monoculture. So, for example, if you think of these areas in, I think in the US, where you have all these almond monocultures, this is really bad for as a carbon sink. So even almond milk might be good in other ways. It's actually bad when it comes to carbon sink, because it actually depletes the soil if you always have the same plant and you grow it every single year, and you always on big vast majority of the land you grow the same plant. And this is really one of the important changes you have to make. And I want to ask you all, because you're from different countries, do you know what the change needs to be in your country with regards to the soil? Also where do you think in your country you can improve the soil the best way? Do you know of any methods you can use in your country?
Petra, can I also pose a question?
Yeah.
In the chat from Eamon, and Eamon wants to ask, and this is referring to the farming example of the specific company that you mentioned. So the question is that, do they give their farmers the funding for making this change to agricultural practices?
Yeah, they do actually. They put quite a bit of an investment in. So when they actually did the work, they analyzed all their greenhouse gas emissions and were kind of willing to make a change, but realized that the biggest change they can make is in the supply chain. So what they haven't done, they haven't invested in more carbon efficient machinery and operations, for example, because they said the higher impact they can do is by investing the money in how the farmers do it. And when I actually talked to them, I said, you really should make this into a case study and share it openly or share it on the website. But they were not willing to do this because they didn't do these changes in operations. So they kind of said, when anybody in the public sees it, they will descend on the things where we didn't make the investment. So, but they did make the investment to the farmers. So what do we get in the chat now as methods in different countries?
Oh yes, lots of answers coming in.
Okay, good.
And, so agroecology, limited tilling, intercropping, and less soy production, more polyculture like milpa, less monocultures, more tree hedges, vertical farming, restriction on GMOs, and permaculture, restoring wild ecosystems, nature-based solutions. I think we've essentially given so many different options, and they're all just the right actions we need to take. Soilless farms, restoration and maintaining mangrove forests.
Mm-hmm. Very important, yeah.
Artificial wetlands. Yeah, all possible solutions for our farming problems.
Yeah.
Industrial farming.
This was great. Yeah, no, thanks very much. So there's lots of, like yesterday, I talked already about the students from Nottingham Trent University we had yesterday, but it was actually in partnership with people from Dubai. And in Dubai, actually, it is quite different. That's kind of obviously totally different climate and so on. For them, actually, one of the focus is to, you can imagine, if you think of Dubai, there was a lot of area transferred into hotels and things, and actually this is where their biggest also where the soil they had actually was storing the biggest carbon. So actually they kind of have to change, if possible, change some of the wetlands and so back into the wetlands that they had before they started to try to build it all up and to make hotels on it and things. So this is what they saw as one of the biggest impacts they could have in Dubai. And so that's quite different from country to country. But I would encourage you to find out what it could mean for your country, and whether your university, for example, you might have an estate, you might have grounds in a campus where things could be done. And this could be things like even planting trees, no? Because a lot of people are actually doing the opposite. They kind of, I don't know if this also is in the US the case, actually instead of having lots of trees in front of their houses, they kind of cut down the trees and make lots of driveways in front of their houses. They can park all the cars in front of the house. At least they do it here in the UK quite a lot. And obviously this is the opposite what we should do. First of all, we shouldn't drive so much with the cars. It's a question whether every household does need 2 cars, but also to actually replace all these trees with actually driveways and parking spaces in front of the house is obviously going in the wrong direction. And so it could be, for example, to say on the campus, can we plant more trees? Can we actually increase this? And when you actually choose trees, I think it's also quite important that you, because there's quite a difference what you are planting. For example, if you go for native trees, which are actually part of what used to grow there, it has often a lot of benefits. For example, I was just recently, because there was a big movement here from the Woodland Trust in the UK to plant trees, and that everybody should at least plant 2 or 3 trees. And I thought, okay, we have a tiny garden, but I thought we can still manage 3 little trees in our garden. So, but it was really quite interesting to choose these 3, as I did choose 3 different ones, but they're all native varieties, and one even is supposed to give home to 200 different species when it has grown. At the moment it's tiny, it's only 20 centimeters. So it was actually the encouragement for everyone to make this tiny change in your garden. Obviously, if you have only a little bit of space, you can maybe only plant 3 trees, or your university hopefully has more space, I would guess, so you can plant hopefully more than 3 trees. But this might be already one of the where you can have an impact by actually increases again. And then obviously doing things like changing, for example, in the UK we would use compost, which is actually has included peat. But peatland is actually one of the biggest carbon sinks as well. And so it's really important not to buy compost where peat is included, and to maybe even start to make your own. It's kind of like peat in the garden, where you kind of just put leaves and sand together and you get something which is similar to peat and which you can use to grow your own plants in spring again. So these are all the little changes you can make in this regard to increase the carbon sink. And I want to talk now about one which is actually one of the biggest carbon sinks, which you haven't, I think, mentioned in the word cloud at all. And I call it the carbon sink of the past, because it's all the fossil fuels. So if you think of fossil fuels, they are actually organic matters which were degrading like millions of years ago. They were then pressed by stones and other sediments going across. And this is how we got oil, how we got coal, how we got natural gas. And so they are all actually made from carbon, but from carbon in the past. So they are carbon sinks, but carbon sinks produced millions of years before. And the problem when we actually start to burn these fossil fuels is that we add to the carbon cycle of the current carbon cycle. So instead of leaving it in the past and say, okay, this is it was part of the carbon cycle, but it's not anymore part of the carbon cycle, we are actually adding it to our carbon cycle, therefore put more and more carbon into the atmosphere, and this is how we increase our temperature. Yeah, so it's really, really important that the fossil fuels stay in the ground and that everything you can do, be it to encourage your university to divest from fossil fuels, so that anything they are investing in is not in fossil fuels anymore. Divest in your own when it comes to having the right bank account yourself, whether you want to encourage your family or anyone else to actually choose the right bank accounts and so on, so that actually there is a divestment away from fossil fuels, which is really, really important. And part of fossil fuels, there's one product which we also need to look into, which is linked to the fossil fuels, which I haven't mentioned yet. Can you guess what it is? Maybe put it in the chat or just say it. What is made from fossil fuels as well, which we use a lot every single day?
You've got it. Plastic.
Yeah. Yeah.
So yes, everyone got that right as well. So yes, so dependent on plastics and so much crucial roles that plastic plays in our life right now.
Yeah, and this is also a product from fossil fuels. So it's really important that you also try to reduce the amount of plastic you use, and especially that you don't use single-use plastic, obviously. But even other plastic, it might be a question whether it's really good, because it's again taking things out from the carbon sink of the past, which is not a good decision to make. So this is something to consider as well. And if you look into biodegradable plastic, there's obviously the problem that sometimes something is declared as biodegradable, which is really still from a fossil fuel. It still comes from the carbon sink of the past. It's not from the current carbon cycle. But you have obviously also biodegradable plastic, which are coming from the current carbon cycle. So they are made by starch, for example, from potato peels or something like this. Which is better than biodegradable things made from fossil fuels. But still it's a question, do you need all this packaging, or could it be replaced by something else, by something you reuse, or which maybe it's not necessary at all to use all this packaging. So it's a big question we have to consider. Yeah, this was all about the carbon sinks for the moment. Here's a bit more on the slides, which I think we will share with you afterwards, about what is the carbon sink and how can it be improved. So there's especially, I want to make you aware again of the drawdown solutions. So the drawdown project, which is all the people who actually try to figure out what are really the high impact solutions we have worldwide and which we should implement. And one is, for example, the regenerative agriculture, which we should do. And you can see here at the side a few of the key features that, for example, the crop rotation I just explained to you now. Okay, so this is the first slide deck, and I will start now sharing in a moment the second slide deck for the second hour. And we will have a few more slides, and then you have an activity which you do by yourself. So if you do need a glass of water or something, please stay with us another five minutes approximately, and then you can do your activity, and you could also obviously do it very fast. Your activity, you have 10 minutes and get a drink or so while you're doing the activity. Okay, so I'm starting with the next slideshow. You can see the slides, yeah? Otherwise people start to complain, or can you see the slides?
Yeah.
Good.
Yeah.
Good. So far we have talked a lot about carbon. We haven't talked very much about methane or the other things. So do you know what the difference is actually? And this gives us a bit away what you can see here on the left-hand side. If you, for example, have a molecule of a refrigerant gases, you remember these are the things which also have a high impact and belong to the high impact solutions. What is the difference between a molecule of this refrigerant gas and, for example, a molecule of carbon, or a molecule of methane and a molecule of carbon? Does anyone know the answer? Also speak it out or put it in the chat.
Petra, could you repeat that question again?
Yeah, if you have a molecule of refrigerant gas and a molecule of carbon, what is the difference between the two? And the picture maybe gives us a bit away. What is the difference between the molecule of carbon compared to the molecule of the refrigerant gas? But it's in each case only a molecule.
I think there are already two question answers. There's one that says different global warming potential and one that says greenhouse effect potential. I would also add to that maybe the time of warming could differ as well.
Yeah, this is right. That's very good. Yeah. So it is really different high global warming potential. So, for example, some of the gases, like refrigerant gases, have a much higher global warming potential than others, as like carbon, for example. And methane, for example, has also a higher global warming potential than carbon. So in this case here on the picture, you can see 21 times more higher global warming potential. But as you just mentioned as well, it's a question how long it stays in the atmosphere, and this is also different. For example, methane does actually go way faster in the atmosphere than carbon, so carbon stays longer. But obviously, what we have to consider is that that everyone is telling us we have really the next 10 years where we have to make the drastic changes, and we have to bring everything down. So and I think, as far as I know, methane stays in the atmosphere for approximately 12 years. So I think we need to cover all of the different greenhouse gases. So we need to reduce all of them if we can. So the high impact activity should cover all the different gases, but obviously with some we have higher impacts than with others. So maybe changing refrigerant gases, like drawdown is suggesting, might have a very high impact because the gas which you then use as a new gas has a lower global warming potential. Yeah. So therefore, what is really important is that all these different gases we have, obviously it would be very confusing for the public, for everyone, if we would sometimes talk about methane, sometimes about refrigerant gases and about carbon. So people would get really confused if you would have like 20 numbers instead of one, if you report on a company or on a country or something. So what was agreed about 20 years ago, that we express all the emissions as carbon dioxide equivalents. Yeah, so whatever a person produces or a company produces or a country produces, it might be methane, it might be carbon dioxide, it might be a refrigerant gas, but it's all expressed as carbon dioxide equivalents. And in every country, you can find this information, as every country is producing their own set of carbon dioxide equivalents for their own country, because every country is as when you calculate them, you have to take into account the energy mix of the country. So for example, if you have a country which has loads and loads of renewables, then the carbon dioxide equivalent will be much lower than if you have a country like Australia, for example, who use a lot of coal for any production. So the carbon dioxide equivalent will be much higher. And because of this, you will have all different carbon dioxide equivalents. So you need to find out what your country is giving as numbers for it if you want to calculate it from scratch, kind of. But it will be different. And when you're working in a company, they will do these calculations quite carefully. So, for example, if you imagine you are a drinking company like Coca-Cola, for example, and you can have the chance to either put the Coca-Cola into glass containers, also into a glass bottle, and you can either have a normal glass bottle which you just throw away, or you have a glass bottle which gets recycled, or you have a glass bottle which gets refilled. This will all have different carbon dioxide equivalents. Or if you kind of decide, okay, no, we are putting it into aluminium can, it has a different carbon dioxide equivalent. Or if you decide, okay, let's put it into a plastic bottle, we have again a different carbon dioxide equivalent. So a company like Coca-Cola can really look this up and say, okay, so how do I want to package my drinks? As if they want to consider to reduce their carbon emissions, they can find the numbers here by looking at the carbon dioxide equivalents and can decide to choose one material which actually has lower carbon emissions, which includes its carbon, methane, everything together. And this is really done by most companies, but it's also done by countries. As I said, it's used for countries for their overall, what they kind of report as their overall emissions. But it's also used, for example, of universities. A lot of universities are reporting on this now, so they will also use the carbon dioxide equivalent. So this is something to consider when we go to the calculations in the moment. So any human activity, anything we are doing has this carbon dioxide equivalent. So for you all now, whether you just got up and you had breakfast, you had maybe a shower, or you didn't have a shower, you cleaned your teeth, or you didn't clean your teeth, everything you do and use, whether it's a toothpaste, the toothbrush, the water, the cereal you might have eaten for breakfast, the coffee you might have drunk for breakfast, everything has an impact. And so it's really everything we are doing, every single thing comes together and gives this impact that we are all causing these carbon dioxide equivalents through our daily activities. And this can be quite complicated. So for example, if you think of air conditioning, I don't know how many of you are sitting in an air conditioned room at the moment. With air conditioning, for example, it's not only the refrigerant gas, because it's obviously cooling a person down, so it's a refrigerant gas, which is used, but you have all these things which are actually used to make the air conditioning unit. So because when we do these calculations, we look at the whole life cycle of a product, which means that we look how the product is actually produced. So how do you make a higher air conditioning unit? Do you need coal, oil, gas for it to actually make this unit? And then obviously once you put this air conditioning unit into your house or into your company, into your university, and you're running it, then you need gases and so on to run it, electricity to run it maybe. And then at the end of its life, you dispose of it and it goes to landfill also. And again, you have greenhouse gases at the end of the product life cycle. So all this is actually taken into account when you make this calculation for the greenhouse gases. So it's quite complicated, but I say it's not impossible for you also to calculate it if you want to. Otherwise, I share with you some sources where you can find these numbers. And then obviously we might forget about some. So methane, as I said, is also one of the greenhouse gases, and you will all know that it's cows and sheep are causing methane, but it's also sewage. You will have methane, and you have lots and lots of methane coming from landfill. So the moment you put anything on landfill, and have these really big kind of rubbish heaps, you will have lots of methane developing there. So if I go just back to methane, when you have actually one molecule of methane, it has 24 times the warming potential than one molecule of carbon. Yeah, so it has a much higher global warming potential. And 24, as people do disagree on this one, I think it's between 15 and 24 times they're calculating how much more warming potential is. But the joint message is all of them say methane has a much higher global warming potential. So it's something you really need to look into when you want to reduce the greenhouse gases. And all of these things come together. So you might say, okay, it doesn't matter if I actually do this or this. It's only me, it's only one person. But at the end, all of these things are adding up. And you can see even when we go for the two scenarios, which are still the ones we think it's good, kind of, as if you go for 1.5 degrees or 2 degrees, for example, with regards to heat waves, you have up to 1.1 months if you go for if you will go for 1.5 degrees. We will have up to 1.5 months with 2 degrees. If we look at fresh water, it will go down, as this is specific in the Mediterranean, it will go down by 9% compared to going down by 17% in the 2-degree scenario. If you look at heavy rainfalls and increase in intensity there, it goes up by 5% under 1.5 degrees. It goes up to 7% in 2 degrees. If you look at the sea level rise, it will be 40 centimeter with 1.5 degrees and 50 centimeter with 2 degrees. And obviously, if you're living close to the coast, if you have a city like New York, London, and so on, which are kind of influenced by sea level rises, this will make a difference whether it's 40 centimeter or 50 centimeters. So each of these little activities are adding up and are kind of deciding whether we will go for 1.5 degrees, 2 degrees, or the 3 degrees, 3.3 degrees we are actually at the moment heading for if we don't do changes. Yeah, and I did see, Popper, that Larissa had a question, that she put up her hand. Larissa, do you want to say something?
Yeah, I was actually wondering about the difference of carbon dioxide and methane. You said that it's 24 times more potent, but it's also much more short-lived, right, compared to CO2. And sometimes I'm a little bit insecure about the carbon equivalent, if that's really fair, especially in relation to methane, since I'm not sure if I remember it correctly from a class that I took, but they said that normally methane would be like taken up also through photosynthesis and some other like biological processes. And we had a discussion if the CO2 equivalent is actually the right measure for methane to calculate it to, like to convert it to a CO2 equivalent. Could you shortly give me your thought on that?
Yeah, I mean, there are these problems, and I do agree with you that there is a bit of an issue, but it is, I think at the moment we need to look into it quite strongly because of that we have to draw down very fast with our emissions. And I think then even if methane is only staying in the atmosphere for about 12 years or so, it is still important at the moment to get it down. But obviously, if we do manage to really do our changes fast enough, and then in 10 or 20 years time, we actually have managed to get ourselves down, then I think it would be a very important question to look into it more and say, okay, maybe with methane as like meat consumption, so we don't need to be so careful as with other things, kind of, because of the other issues you have mentioned. But I think for the moment, my opinion, as it's my personal opinion on it, is that we do all of the things together, and we need to do all of the things together. And the carbon equivalent, I think the benefit of to express it in carbon equivalence is really that we have this kind of joint measurement for it. So I think this is actually helpful because otherwise people wouldn't really understand what do we have to do with methane. But you might be right that we have to have different targets for and separate methane from the other. I'm not fully sure about this one.
Thank you so much. It's just nice to have another thought on it and just think it through, because if you start getting into this topic, it can be very difficult to get a full picture, and it's always nicer to have a full picture than just half of it.
Yeah. No, but definitely. And I think maybe you can, with your action plan, I don't know if you want to look into this topic, also with the communication around this topic. It might be something you could do for your action plan in session 4 if you're interested, no? Also if you kind of think that you have a lot of discussion around this topic, it might be something where you want to have a kind of bit of a communication strategy, how you would like to communicate this and how you want to also highlight to people that some other things are really as important or even maybe more important, because obviously you get sometimes people who are very they have the feeling once they are vegan, they have covered it all. And this is really not true, because you have to do all the other things. You have to look into flying and everything else you're doing. You can't just say, oh, I'm a vegan, now I have covered the topic. This is not true. This is, I'm very sure about, not true. You have to do all the other actions as well, and especially getting away from fossil fuels and things like this. Okay, so then this is only a starting point. I want you to now do your own lookups, your own things, and it's what we are using is the BBC Food Carbon Footprint Calculator. Obviously, it's a bit from the perspective of the UK, so you might have, depending in which country you're living. As for example, if you have bananas just next door, kind of, and it's not a long transport, you might have a bit of different results than others. But I think for many countries where you're from, like when you're from another country in Europe, or when you're from Australia or the US, also you will have similar numbers for it. And obviously feel free to use a different food carbon calculator than the one I'm offering. But I think to make it that everyone is sharing the same tool, I would encourage you to go to the BBC Food Carbon Footprint Calculator. And I think we have it in the chat now as well, that you can find it. And I want you to look at what is going to, choose 2 foods you really like and 2 beverages you really like. And then kind of, first of all, find out what is the carbon footprint and share this with us in the chat. And then what is happening when you substitute your chosen food with an alternative of your choice. For example, if you really like to eat pasta, but you say, okay, let's try rice, maybe it's a better option. What would happen? Or what would happen if you would swap it with potatoes? When do you actually get a lower carbon footprint? And then the same when you use coffee or tea. So you might be really drinking 4 cups of coffee per day. What would happen if you would go down to 2 cups of coffee per day? Or what would happen if you say, okay, let's try tea instead? So I would like you to really look at these different things and then share your insights in the chat. And you have for this activity 10 minutes. And as I said, you have also the possibility to get a drink or get a coffee or whatever you need doing this 10 minutes, but because you can do it faster than 10 minutes. But please do start to put in the chat whenever you are ready, and we will look at the chat and see what you're answering. And you could also answer to each other. For example, if you don't feel you don't need a break in the two-hour session, then you can just start to chat also with your colleagues in the chat about the high impact carbon solutions you can find here. Okay, so then if you have a question, obviously put it also in the chat. Yeah, thanks for sharing your ideas in the chat. It was really nice to see the different things. Obviously, it's questions you need to ask yourself. So how much coffee do you need? How much wine do you need? And so on. I saw the wine. Obviously, wine and cheese is a really nice combination, but you could put these 2 together and look for it and see what you can find then. So you might decide, as obviously what you want to change, it's up to you. I found often some things are not difficult. What I realized when I did the exercise, for example, was that rice had so much more than potatoes in the UK. And for me, kind of to actually replace a lot of times now potatoes, to think more about how can I cook for my family, as we have 4 people with potato instead of rice, is actually at the end not. I don't find it hard, because I do like rice, I have to say, but actually potatoes you can make lots of nice stuff with them as well. So there might be some choices you can make which are not as difficult as some which you really like. Maybe you really don't. Maybe you feel like you can't function when you have less than 4 cups of coffee per day. So obviously these are the choices you need to make, and do use the tool more in your own time to explore a bit more, because I think it's quite useful to see all the differences you can make in your own life. And obviously, as I say, if you then add it up, so if for example, you ask your university maybe in their catering to do these changes, then it might really add up. No? For example, if you could ask your catering, as if you are coming from a country where rice is not produced next door, which a lot of us, I think, are from countries where we don't produce our own rice. And if you would be able to say, can we actually offer more potato-based meals in the catering, it might be an easier choice to make and an easy change to make for your catering in the university. But it is adding up, and you obviously are feeding 1,000 people or 10,000 people a day, kind of, no? So you might look into all these things. It gives you maybe hopefully a few first ideas. I want to now share the next activity with you. So this is the one we have already had the link already in the chat. If you could please put it again in the chat. It's the one from the Vegan Society. What we have done, we have sent you a document where you have 2 different meals, and you can choose one of the 2 meals. And you kind of in your group, as we will break you into different groups now, you might say between you, so you will be 6 people in the group. So you might say, okay, can you look up what a tin of tomato, how much carbon it has, and then someone else you might send off to look into rice or into pasta, as whatever you choose as your meal. So you divide the different ingredients you need for your recipe between the 6 of you. Each of you looks one up, then you put it all together. You calculate how much carbon this meal has. And then your challenge is to make it more carbon friendly. So what could you do? Also when you have actually the full amount of the recipe we have given you, the way it is there on your document, can you identify a substitute ingredient that would result in the recipe having lower CO2 emissions? So it could be, for example, what happens if you replace the tin tomatoes with fresh tomatoes for certain parts of the year when it's local and in season? Or what would happen if you replace pasta with rice and so on? So try to see how you can make your dish more carbon friendly. Another thing you might want to try is when you change the region of origin. So for example, if you choose a recipe which has meat in, what happens when you take the meat not from a country on the opposite side of the world? What would happen if you would get it actually locally sourced? Yeah, and so as I would hope that you would get on. We will have Ashley, Rajul and I will pop into your groups, but when we see that you're getting on, we will just quietly go out again. But in case you need to ask us a question, you can ask us a question. But otherwise, we just pop in, don't say anything, and pop out again when we see that you're working hard on making the answers for this, to get actually the carbon-friendly meal together. When you come back after 10 minutes, please put your solution into the chat, also after 10 minutes. So you have now 10 minutes in your groups, and Scott will make sure that each of you gets now a link so that you can go into your group and get started on working on your recipe. Also, you didn't have enough time to change ingredients. Okay, I think maybe next time we have to make it a bit longer. Hopefully, I think this tool is really good if you want to, anything you like to cook, anything you want to find out, to actually put it together, and then you can really make a carbon-friendly meal. And obviously, again, it's something you might want to recommend to the catering in your university or in a company you're working with or anything, because for them it's a really good tool also to understand how they could make a carbon-friendly meal. And a lot of people are already doing it, so you can go into some companies also where they actually kind of try to really understand what are the small changes you can do to actually reduce the carbon quite a lot. And I'm quite fortunate that, for example, here at Nottingham Trent University, we have a really engaged head chef who is very engaged, and we have climate action days here where he actually calculates everything which is on offer. At the moment, obviously, there are not so many students, but normally we have 32,000 students, and a lot of them are eating in the university. And on these climate action days, he calculates every single, I think it's always at least 6 different options on offer, and everything gets calculated by him, so that you can really make a very informed choice what you want to have, whether actually it's potatoes with beans, which is a very popular thing in the UK, or whether it is something else which is your lowest carbon friendly food. So this might be an idea for your own university as well. Okay, so we have a lot of people who have looked at things now. So I go back to share my screen, but as I said, use the tool maybe a little bit more. So what I would recommend to you is to get the book on the left-hand side, which is called How Bad Are Bananas? And what Mike Berners-Lee, who's a professor in Lancaster University in the UK, what he has done, he has really calculated for years and years and years the impact of different actions. So you can find all sorts of things in there. So you can find out about data center, about sending a text on a mobile phone. You can find out about drinks as well, also like wine or something like this. But also you will find some unusual things. For example, when I looked at it recently to prepare for this session, as last year with the other cohort, I realized that there is something on Christmas. For example, it's about how you can avoid an excess Christmas or excess any celebration you might have. You might be celebrating a different religious feast, but I think when we celebrate, we all have normally a lot of nice food, as we have lots of nice lights, we have all sorts of things like maybe sending cards to each other. So whatever you might celebrate, you can have an excess version of this, or you can have a normal version. And he has actually, in his book, he kind of describes what a low carbon Christmas would look like, and it would be still very nice. It would be still lots of nice food, but it would be avoiding food waste, because you can imagine when you prepare these celebrations, people tend to cook and cook and cook, and at the end everyone is totally stuffed and has the feeling, oh, I can't actually eat a single whatever is on offer anymore, and people don't eat the food, and a lot of things goes into waste. And I think this is really adding up, kind of. And if you imagine that a lot of people are cooking too much for these festivities, and then everyone, as normally everyone would visit everyone, and everyone thinks, oh, I have already eaten enough, I can't eat any more. And so a lot of food gets wasted. So this is part of the excessive Christmas which he has in his book, but also other things like, for example, in the UK, it's very, very common to send loads and loads of Christmas cards. And he actually, for the low carbon friendly Christmas, he only allows 20 Christmas cards. He kind of says 20 Christmas cards is enough, not more. But some people in the UK have 150 Christmas cards or more they are sending. And it's a question whether you, for example, could replace it with emails, which have a much lower carbon impact. And the same with lights. Obviously, we do like to have it all illuminated and so on. But it's again the question, do you have LED lights or not? So these things, as if you look at in this chapter on the excess Christmas, you go into kilos of which you could avoid, kilos of carbon emissions. So it's really a high impact solution. And so some of these things are quite surprising. And the one which comes directly after Christmas in his book is actually to buy a new carpet. And you might think, oh, new carpet, what is a big deal? But actually thinking it through properly can actually be one of your low carbon impact solutions, that you have only your high impact solutions which only cause a low carbon. So it could be something very which you haven't thought about, like buying a carpet, which otherwise could really increase the carbon emissions you are causing. And so there are loads and loads and loads of ideas in this book. So I would really encourage you to have a look. The other one I want you to also look again at is really Drawdown. What I have put here is the book, because I really like the book because it gives all the solution on 2 pages. So you can really, for example, on refrigeration, you can look it up on 2 pages, all summarized nicely. But obviously you get the same information on the website, but I find the book a bit easier to read. This is why I like it, and I would recommend to buy it in addition to the book, to the website. So these are the 2 things I would recommend, and all the things we are doing now actually are based on the calculation in How Bad Are Bananas. So we are assuming that 18 grams of carbon dioxide equivalents are actually as much as this bucket there, which you can see there. So it's not actually, obviously you can't see carbon dioxide equivalent, so it's only a visual image, because a lot of people find it easier to see something in front of them and to kind of do it from what they, from this kind of visual image. So I would encourage you to use either way. As if you're better with numbers, you just tell me the number. If you're better with buckets, you tell me the thing in buckets. And I want you all to put this information in the chat. I think we are too many to just shout out, but I want each of you to be involved, please. And you either put higher or lower in the chat. Yeah? And sometimes I will also ask you for a number. So if you send a text to someone, like a customer or a colleague or a friend, do you think it's lower or more than the bucket, as than 18 grams of carbon dioxide equivalent? Is this lower or higher? And Ashley and Rajul will summarize what you are saying. So everyone, please give an opinion.
So far, I see a good mix of both higher and lower.
Okay. It is actually a lower. Then you can see it's only tiny slice of the bucket, as you can see on the right-hand side. and it's 0.014 gram of carbon dioxide equivalent in the book from 2010. Also the book has been published in 2010 and then again now this year in September. And when you look at the September edition where he did recalculate everything, it is actually slightly higher, so it's 0.8 gram CO2, because a lot of people have different phones now, and he's really basing it on different makes. So he will also tell you exactly which mobile phone he has used for his calculation. But because our mobile phones are much more sophisticated than they were in 2010 and can do much, much more, they are more carbon intensive as well. So it's actually slightly higher now, but it's still quite low. So if you'd say, okay, let's send instead an email, as you put exactly the same amount of sentences in an email, do you think it's higher or lower?
Again, I'm seeing a good mix of higher and lower.
Okay, great. Okay, it is slightly higher. So it's 4 gram now, but when you look at the other number from 2020, it's actually depends really on what you're sending your email on, whether, because they are very, very energy efficient. Sometimes it depends whether you have a laptop or a computer and so on. So it can be between 0.03 or 26 gram for the message, for the email. The moment you put an attachment to it, it goes really up. So it immediately adds 50 gram to it if you have one attachment. So it might be, one thing might be to think about attachments. How much do you need to send them around, and whether you really need to send all the attachments to all these people. So it might be one way of avoiding to have so much carbon emissions with your emails. Obviously, it's a data center and everything which comes to it as well. So let's say, okay, we are sending the same information now as a letter. So instead of saying Merry Christmas in your email, you are saying Merry Christmas in the letter. So what, or any other thing you want to say in a letter, but it's a very short message you want to put in the letter. It's higher or lower?
I'm seeing a majority of people thinking higher.
Yeah, that's right. You're good. It's much, much higher. No? So you can see it's 200 gram carbon dioxide equivalent, so much higher than actually sending an email. So if you can actually avoid sending a letter and instead send an email, this might be often a better solution. No? And Perla is raising the hand. Perla, what would you like to say? Perla, you have raised your hands. Do you want to, Perla Estrada?
She's mentioned in the chat that her answer is higher.
Also, okay. Good.
Quick question, Petra, if you don't mind.
Yeah.
Does it take into consideration the carbon footprint of the computer as well, and like all the all the digital devices that we need in order to send the email versus the post mail,
Yeah, it takes, as he always explains what he takes into account. As he's quite precise in his book. Obviously, for some things, like for these emails, for example, he's not assuming that you store it all in the cloud and that you actually use this enormous data center. So when you look into his book, the data centers are actually coming under the really, really high impact, as they use a lot of kilogram of, so it's actually the question, for example, how much do you need to store in the cloud? As this is a different issue than sending an email. But this is really something where the high impact is from these kind of things, and he's very precise in his book what he includes and what he doesn't include. I hope this answered your question. Yeah.
Yeah, it does. Thanks.
Okay. So I will explain it with the next one how precise he is. So he's kind of now assuming that you bring the message which you had in your email or in your letter to a meeting. So because the person who you want to tell this is only a mile away, and you go with a bicycle to the person to deliver the message. And for this calculation, he takes into account the whole life cycle of the bicycle. Obviously, that you have to make a bicycle and how much you use it. And so he assumes that you're using it regularly, but now you're driving this extra mile to deliver this message. And he also assumes that you have to you burn extra calories when you do this, because you burn, as you go for another mile, so you burn more calories. So he's actually has calculated how much you have eaten in the morning, and he's quite precise what you have eaten. As he has different scenarios actually, but the one which this is based on, that you had actually cereal with milk for breakfast to burn these extra calories, and the cereal is locally produced, the milk is locally produced, but both are packaged in plastic. So you can see how precise he is in his calculation. So after having taken all this into account, that you had to have extra calories eaten during your breakfast to drive this extra mile, do you think it's still less or more than actually sending a letter?
I see a mix.
Yeah, do people? Okay. It is actually less than a letter. So even if you have to eat to actually drive this extra mile, to burn this extra calories, it's still less than a letter. So which is yeah, so it's beneficial actually to just drive with a bicycle to someone and deliver the message in person than to send a letter, if you can do this, no? So now he's, as we are assuming that you're taking a bus, obviously then you don't need to have eaten because you're just sitting down, you don't burn any extra calories. And this is assuming an average occupancy of a bus in London, so for this calculation. So what do you think? Is this more or less than going with a bicycle?
Looks like everyone's agreeing that it's higher.
Yeah, this is good. It is 150 gram according to the 2010 calculation. In 2020, you can see that it has gone down all the way to 6 gram. And this is actually assuming that the bus is that it's actually driven by an electric or other powered bus, but the electricity for the bus is also coming from a renewable source. As it's made from a renewable source. So if you, in this case, you can really go down a lot, even with a bus. But obviously you can also go up totally in the opposite direction if you use diesel or something. So you can see the 2.5 kilogram going in the other direction. So it's then much more. Okay, so then let's say you are going with a tram. Do you think the tram is better than the bus, or is this less than the bus?
Looks like the majority are thinking lower.
It's slightly higher, and this is because the average occupancy of the tram is during the day often, as it depends obviously again on the city. In this case, he has actually taken Manchester as a city because I think he had the data for it. It depends really how busy your trams are, but in a lot of cities the trams are not very busy during the day, so they are maybe busy in the morning and in the evening when people go to work, but not during the day. But you still have to move a really enormous amount of steel around because or whatever the material is made of, it's made from steel. So therefore, because it's bigger than a bus and you move more around, you actually are using more energy to move it around. But again, obviously, it depends also how the energy is made and all these things again. Okay, let's say you're taking a taxi instead. Do you think a taxi is more or less?
Looking like it's more or super higher.
Super higher even. Okay, yeah, that's right. It is much more, no? So it's 710 gram carbon dioxide equivalent, and even with more efficient cars, which we might have now 530 gram now. And this is again only for the 1 mile. So you can see how much it is actually only to go 1 mile with a car, how much is adding up. Okay, and the next one is actually where obviously it is higher because we are going a bigger distance. So this one is assuming that you go with a train from London to Glasgow. London is in England, Glasgow in Scotland, and the journey takes approximately 4.5 hours. So what do you think? What is your guess? How, in a number, how many kilogram will you be kind of emitting by doing this, by going with a train for 4.5 hours? And give a number, as I say, guess how many kilograms you would expect in this case.
I'm seeing everything from 180 to 150, 1700 kilograms, a good mix.
Okay, so it is actually 120 kilogram. So and now it's 64 kilogram again. Trains have become more energy efficient, but you can see also, especially when you see it in buckets, how much more it is than all the other activities we had before. So how much actually, maybe not going on this one train journey, but doing video conferencing instead, how much actually you could save by not going such a long distance. So let's say you're going with a plane the same distance again, as it's London to Glasgow, exactly the same as a train, as you have done by the train. And what now I want to ask you, how much multiplied? Also is this is this 10 times more, 20 times, 3 times more? What is your guess? How much more is this when you go the same distance with a plane? And this applies to all countries. So it's not only to the UK, it's for any country when you exchange a plane with a plane instead of the train.
I've seen 8 times as much, 10 times as much, 20 times as much.
Okay, it is actually approximately 4 to 5 times as much. So you can, as a kind of a rule of thumb, you can say, okay, it's 4 or 5 times as much if you go anywhere by plane instead of the train. So actually, for a lot of things, if you do want to travel and you have to go somewhere, it is always really good if you can replace a plane journey with a train journey. So that, for example, people who have to travel from within mainland Europe between cities, it would be much better to take the train than to take a plane. And I think this will be applying also to the US. It will be, I'm sure it will, I know that it will also apply to the US. So wherever you can actually replace the plane with a train, it would be better to take the train. And obviously, if you can decide not to go at all and to maybe do a video conferencing or video training as we do at the moment. So if you imagine we would have all actually gone to Yale to do this training, how much actually emission we would have had. And obviously by actually every one of us only being in front of a computer at the moment, it is much lower. So it's a question whether you want to maybe replace some activities with video conferencing, even when we come out of lockdown or whatever you are in at the moment with regards to COVID, and we can travel again. So this might be the better option. In case you want to explore this more, these are the links actually to look at transport and meetings, and if you replace a meeting where you would have taken the train or the plane with the meeting on the screen or so you can look these up with these tools. And now we're coming for next week, because next week we are putting all these different things together. So I would encourage you to do, not next week, as in after in the new year, to do the En-ROAD simulator. And we will send you an email where you also will have the link. And I would encourage you to put all these different solutions together. So when you look into the En-ROAD simulator, you will have high energy efficient efficiency with cars, with transport, for example. You will have things around food like methane and how you could change this. You will have carbon things with regard to agriculture. You will have afforestation, to plant more trees as a solution. So you have all these different solutions there, and you have solutions which we haven't really talked so much about yet, like what would happen if you would have a carbon price, what would happen if you would have a tax on coal and so on, and on oil. So try to put this all together, come up with ideas on how you could actually use all these different solutions to make a scenario where we actually temperature in the worldwide will only go up to 1.7 degrees and not more, so that we keep it in the lower region where we don't have such a damaging impact. So this is your optional task until we see each other again. Obviously, you have nearly, I think now, 3 or 4 weeks to do it. It would be nice if you would do it. In case you want to share your scenario and how you have achieved it, this would be an option in the next time. Do send me an email or Natalia an email that you want to share your solution, and we would and you could share it with everyone in the next, when we have our final meeting, session 4. And also please do send us, as we sent you this email, please do also choose your solutions you want to focus on in session 4, because besides looking at all these high impact solutions, how they all could be put together, we will very much focus on the high impact solutions you can put into place with regards to your university, to your work, or anything else where you can work with a group of people on implementing something. This will be the main focus in our session 4. And I hope I will see you all there. I wish you a very good start to the new year in the meantime, and a good break if you have one. And I will stop share now, and I hope I will see you to say goodbye and see you all one more time. And if you have a question, I hope Scott makes me the host in a moment and you can stay behind so that you can ask me a question if you have one. And it would be nice if you actually do share your video so that I can see everyone and can say goodbye to everyone. Don't see many emails yet. Maybe I have to click. Ah, now there are people. First one we're still with names.
For me, it says I can't turn it on because the host has stopped it.
Oh, really? Okay. This is strange. Okay, but it's nice to see you all. I hope you enjoyed today's session, and I see you all again in session 4 for the final session and to make big plans. Okay? So bye, everyone. See you. Bye.
Bye.